Hi students, we're going to continue problems with random variables of probability. So let us start. In school, there are two sections, English and French. This is English and this is French. To participate in a marathon, the director of activities in the school chooses from the French section a group form of two students of the GS. So this is the French, two of the GS, and the three of the LS. So the total here of the French is 5. From the English section, a group of three students of the GS and two of the LS, as you can see, 5 also. The total here, you have 5, 5, 10, GS 5 students and LS 5 students. So when you can do a table, better to do a table, okay? Consider the following events. F, the three chosen member represent the French, E, the English, G, the three members chosen is formed of two of GS and one from LS. So what is G? G is G. So I want to pick two GS and one LS. Okay. Show that P of G is 5 over 12. So I want 2 GS. So how many GS here? I have 5. So 2 out of 5. 1 LS. How many LS? I have 5. 1 out of 5 over total, which is 3 out of 10. So this is 5 over 12. Calculate the probability of P of F, the three members chosen French section. So I have 3 out of 5, as you can see, French, over 3 out of 10. The P of G knowing F. G knowing F, I know I have from French, so here the sub-universe is French. So I don't take from these the 10, the total, only from the French section. Find the probability of picking 2 GS and 1 LS. So how many GS here? I have 2. So 2 out of 2, 1 out of 3, over 3 out of 5, not 3 out of 10, because knowing from, I know I want to pick from the French section. And P of G knowing E. Knowing E, it means from the English section. So this is 2 out of 3, 1 out of 2 over 3 out of F. But before I continue, knowing F, knowing E, either from French or from English, this is a total probability. Now they're going to ask, what is P of G? What is the probability of the event H? Not now, maybe later. What is the probability of the event H? The three chosen members are 2 of the GS and one from LS representing the French. They want P of G representing the French and the French section, okay? So G and F, since I have G knowing F, so you do P of G knowing F times P of F, so 3 over 120. What I was saying, at Akid at the end, they're going to ask what's P of G, because this is knowing F, knowing E, total probability. So they gave us, to find before P of G intersecting F. If they didn't tell us this one, you can do it directly. P of G is P of G intersecting F plus P of G intersecting E, which is P of G knowing F times P of F plus P of G knowing E times P of E. If this is was asked directly, but however here they do it in steps. Now let X be the random variable equal to the number of students of the GS class chosen. Now you want to pick how many students? We need to pick 3, okay? And from this pick, this is the table, I have copied it here also. Let X be the random variable equal to the number of the GS class chosen. So either you can pick 0, none from the GS, all will be from the LS, or out of the 3 you can have 1 from GS, or 2 from GS, or 3 from GS. So as I told you, random variable, you put all possibilities, okay? And you know that here P of 0 plus P of 1 plus P of 2 plus P of 3 is 1. So now the first question, determine the probability distribution of X. So P of 0. So P of 0, I don't want to pick any from the GS. So all will be from where? From the LS. So 3 out of 5 over 3 out of 10. Here P of 1, it means 1 from GS, 1 out of 5 here. And 2 out of the French, from the LS, 2 out of 5 over 3 out of 10. 2 from GS here, you have 2 out of 5 over 1 times 1 out of 5 over 3 out of 10. And the 3 is 3 from the GS, so 3 out of 5, 0 out of French over 3 out of 10, okay? And if you make the sum, it will give you 100%. And if you want to graph the bar diagram, you put 0, 0 is 1 over 12. This is 1 is 5 over 12, 2 is 5 over 12, and 3 is 1 over 12. Another problem. An air contains 10 identical balls. You have 5 red, 3 yellow, and 2 green. Let me frame this. We draw simultaneously 3 balls, one after the other. Consider the following event. The 3 drawn balls are red. The 3 drawn balls have same color. See, the 3 drawn balls have different colors. You know, either they are red or same color, or see different colors. Calculate P of A. P of A, the 3 are red, so since the red is 5, so it's 3 out of 5 over 3 out of 10. P of D is same color. Either the 3 are red or 3 are yellow. We cannot have 3 green because I don't have 3 green. So as you can see, P of C, they have different colors. In one red, one yellow, one green. So 1 out of 5, 1 out of 3, 1 out of 2 over the total. Now we define the random variable x for which we associate the number of colors obtained. Number of colors. You know, either you have one color, in this case all have the same one color. It means, what does it mean one color? All are red or all are yellow, or two colors. We mean here by two colors either red with yellow or red with green or yellow with green, or three different colors, one red, one yellow, one green. I want to find the probability distribution. One color already I have it, P of 1, which is choice of B. So P of 1 is choice of B. And I know three colors. This is C. So P of 3 is P of C. To find the last one, I do 1 minus these two. No. P of 0 plus P of 1 plus P of 2 plus P of 3 here must be 1. So instead of doing two colors, getting red then yellow, or yellow with green, or whatever, it will take a lot of time because we're talking about three balls. Two red, one yellow, one red, two red, one yellow, one red, two yellow, two yellow, one green, one yellow, two green, two red, one green, or one red, two green. I have six choices and six pluses. So directly I do 1 minus these two. So please be careful. Number 12. In a store, there are two sets of pants. Set A is formed of 50, as you can see, 50 black and 40 white. Set B is formed of 3 black and 80 white. So the total here of set A is 90. The total of set B 110. I have 80 black and 120 white. A customer buys one pant of set A and one pant of set B. Don't forget, I want to buy one from set A, one from set A, and one from set B. What does this mean, guys? It means that it is independent. So I have two subuniverse. This alone here, and the one down is alone. Okay. Consider the following events. E, the two pants are black. F, one pant is black and one is white. Prove that P of E. I want to get two pants. I want to buy one from here and one from here. So you can say black knowing A, as you can see here. Black knowing A times black knowing B. Black knowing A, I have 1 out of 50 over total 1 out of 90, independent, times 1 out of 30 times 1 over 110. So the answer will be 5 over 33. I want here in F, one pant is black and one pant is white. So you can have black from A and white from B, or white knowing A times black knowing B. So here it will be 1 out of 50 over 1 out of 90 times 1 out of 80 over 1 out of 110. plus 1 out of 40 over 1 out of 90, 1 out of 30 over 1 over 1 out of 110. So you get the answer. Okay. Now the prices. This is the table in part A. So I have copied it here. Maybe I'm going to use it 100%. I'm going to use it. The prices of pants are given in the following table. You have the prices. You have 4 different prices. We designate by X the random variable equal to the sum paid by the customer for the price of 2 pants. Don't forget you want to buy one from A and one from B. So either you pay 60 plus 40 or 60 plus 25 or 50 plus 40 or 50 plus 25. So the prices are given as you can see here. So determine the find the 4 values of X as we said. So it's either 100,000, 60 plus 40, or 85,000, or 90,000, or 75. So I want to find the probability of each one. 85,000. 85 is 60,000 plus 25,000. So to get, I want to buy one from A, one from B. So it's probability black knowing A. Okay, so it's 1 out of 50 over 1 out of 90. And white knowing B, 1 out of 80 over 110. So this is the answer. 90,000. So white from A and black from B. White from A, so 1 out of 40 over 1 out of 90 and 1 out of 30 over 110. So you have the answer. That of 90, so we did 90,000. Yes, I think 100,000 is 60 and 40. So 60 and 40, this is 100,000 here. So 2 black, one, we did it up, I think 1 out of 50 over 1 out of 90, 1 out of 30 over 1 out of 110, we did it up, so 5 over 33. And the last one, the 75,000, 2 white, 1 out of 40 over 1 out of 90 and 1 out of 80 over 1 out of 110. So if I want to find the expected value, they ask about the expected value. Let me see. So no, if I want to find the expected value, let me write it. What do I, a person, if he's going to go and to buy, so what he is expected to pay. So we do what? Summation xi p of xi. Summation xi and p of xi will be 100,000. Let me put without the thousand, it's in thousand, times 5 over 33 plus 85,000 times 40 over 99 plus 90,000 times 4 over 33 plus 75,000 over 32 over 99. This is what we expect one customer to buy. Suppose the answer was, for example, X dollars. So if you have per day 20 customers, so how much you expect to pay? It will be 20 times the X payment of for one. Number 13. For the maintenance of a central heating system, a company controls its radiators as follows. 20% of the radiators are guaranteed. So P of guarantee is 20%, 0.2. From the radiator under guarantee, in a knowing guarantee, the probability that it's defective, in a P of D knowing guarantee, is 1 out of 100. From the non-guarantee radiator, the probability that the radiator is defective is 1 over 10. So let me tell you before I start, this is a total probability. Why? Because knowing G bar. So you can do it like this. P of G is 0.0. P of G is 0.2. P of G bar, sorry, this is 0.2. P of G bar sorry, no, let me delete. So P of guarantee is 0.2, D knowing guarantee and D knowing guarantee bar. Yes, this is correct. I was doing it correct, but let me do it. So here, let me do it this way better for you. P of guarantee is 0.2. As we said, it's a 3 table. P of G bar 0.8. Now we have an event which is defective. So here you go to, now we can fill it. P of defect knowing G is 0.01. P of non-defect knowing G is equal 0.99. Here again, P of defect knowing G bar equal 0.1, and P of non-defect, good tool, knowing G bar equal 0.9. Now you can put the intersection. So here I'm not going to write P directly. D intersecting G is equal 0.002. P of D bar, sorry, I'm taking time, equal 0.2. 0.2 times 0.99 is 0.198. 0.198. Why it forms a total probability? Because I have knowing G and knowing G bar. So G and G bar. Here, D intersecting G bar is 0.08. And the last one, D bar intersecting G bar is equal 0.72. If you make this sum, 0.72 plus 0.08 plus 0.198 plus 0.02, it must give you a 1. أنا ما طلع عندي 1 بيكون في عندي mistake. 0.01 times 0.2 plus 0.2 times 0.99 plus so anyway it must be 1. I don't know if I mistake, I don't have time. So calculate the probability of the following event. The radiator is under guarantee and defective. So under guarantee and defective, so it must be 0.02 as you can see from the table. The radiator is defective because it's a total probability. You do D intersecting G plus we have D intersecting G. I want defective, sorry, and P of D intersecting G bar. So 0.02 plus 0.08, so it's 0.082. This is correct. You add these two. Now they want the vice versa. The radiator is defective. Find it's under guarantee. You know this. I talked about it a lot. So you do the property P of G intersecting D, which is 0.002 over 0.082, and you're going to get 1 over 41. Now the radiator is defective. Show that the probability. We did this part B up, I think. Yes. The control is for free if the radiator under guarantee. So if it's guarantee, you don't pay anything. You pay 0. Now it costs you 20,000 if the radiator is not under guarantee and is not defective. So if G bar and D bar, what do you pay? 20,000. 20,000. Okay. It costs 50,000 if the radiator is not under guarantee and is not is not under guarantee and is defective. So you pay what? 50,000. Denote I by X the random variable. So what are the values? Either you pay 0 or 20,000 or 50,000. What's P of 0? P of 0 is P of guarantee. We know that P of guarantee, we did it up. It was 0.2. You can see it here, okay? Okay. Okay. P of 0 is P of G. P of 50,000, it must be G bar and D. G bar and D, where is G bar and D? G bar and D, here G bar and D is 0.08. Okay? And the last one, 20,000, I wanted G bar and D bar, so 0.72. So these are the probability. And I want the expected value. So what will be the expected value? The expected value will be 0 times 0.2 plus 50,000 times 0.08 plus 20,000 times 0.72, so 18,400. So what does this mean? It means if you have one client, it's expected to pay 80 as an average of 80,500. So suppose you have 50 radiators to see. So what you must get money, you must get 50 times 18,400 for each one. It will be 920,000 Lebanese lira. Now number 14. A big store decides to recognize a lottery to attract attention of its clients. This they use to earn U and V. So let me earn U contains two white and so we have U. We have two white and four black balls. Earn V contains five identical counters. Three hold the number 0. I have three zeros. One hold the number 50,000. And one hold the number 100,000. If the ball is drawn is black, he gains nothing. So if you draw a black, you get 0. You don't get anything. If the drawn ball is white, he draws simultaneously three from counter from earn V, 3 from V. Let X be the random variable that represents the amount of money received by the customer. So what are all possibilities here if you want to draw 3 from V? Either you're going to get 3 zeros, so 0. So in this case, you want to get 3 zeros. Or 2 zeros and a 50,000. So 50,000. So you have in this case 0, 0, and 50. Or he's going to get 100,000. In this case 0, 0, and 100. Or 150, 1, 0, 150, and 100. Do you have other than these possibilities? Certainly no. So what are all possibilities of X? Either 0 or 50,000 or 100,000 or 150. So I want to find the probability distribution of each one. What's P of 0? P of 0, either he will get a green. So to get a green, to get black, he does not get anything, not green, نجيب green أنا ما بعرف. So if you draw a black, so how many black here we have? 4. So 1 out of 4. 1 out of 4 over 1 out of 6. Or he get a black plus probability of white, probability of white knowing from the earn V times what? Getting 3 zeros from which earn? From earn V. So Probability of black, we said it's 1 out of 4 over 1 out of 6. Then drawing a white, or sorry, plus, not then, plus drawing a white is 1 out of 2 over 1 out of 6 times independent, because I want to draw from the other urn. I want to draw 3 zeros. How many zeros I have? 3. 3 out of 3 over 3 out of 5, you have 7 over 10. P of 50,000, so he's going to get black first of all. So sorry, a white, sorry, a white. So 1 out of 2 over 1 out of 6. Then he's going to get 2 zeros and 150. So 2 zeros in a 2 out of 3, and 150 is 1 out of 1 over 3 out of 5. Getting 100,000, so the same story. 2 out of zeros and 1 out of 1 for 100,000. And getting 150 is going to get a white, the same one, 1 out of 2 over 1 out of 6 times 1 0, 1 out of 3, 150, 1 out of 1, 100,000, 1 out of 1 over the total. So if you make the sum here, it will be what? 1. What is the expected value here? Expected value, it will be 0 times 710 plus 50 times 1 over 10 plus 100 times 1 over 10 plus 150 times 110. So it's a $30,000. So it's expected for every client to get, for example, a deduction of 30,000 Lebanese lira. Suppose we have 730 customer. How much discount we're going to get? We do 730 times 30,000. It will be 678. 900, maybe 1,000, whatever. Part A, this problem. In an early one, we place 4 counters holding the number 100. So I have how many 100? I have 4. 3 counters holding the number 200. We draw at random 3 counters from early one, and we denote down the sum of the number written. So you want to draw 3. Okay, so what? Show that the probability of obtaining a sum of 200. You want to get 200. To get 200 and you want to draw 3, so you must have 100, 100 with 200. So what's the probability of getting 400? You want to draw 2 out of 4 of 100. You can see it here. 200 here. 2 out of 4 of 100 and 1 out of 3 of 200. So you're going to get 18 over 35. Let x be the random variable associated to each drawing, the sum obtained. In either you have, we can say 400. We want to draw 3, don't forget. Or you draw 100, 100, 100. So this will lead us to 300. Or 200 with 100. This will leave us to 500. Or 200. 200 3 times. This will leave us to 600. So what are all possibilities? Either 300, all 400, all 500, or 600. So what's P of 300? P of 300, you're going to get 100, 100, 100. So how many 100 I have? I have 4. I want to draw 3 out of 4 over 3 out of 7. 500, it means I have 2 200 and 1 100. So 1 out of 4 and 2 out of 3 over 3 out of 7. 600, I want 3 200. 3 out of 3 over 3 out of 7. So if you make 300, 400, what about 500? 500 here. 2 200 and 1 100, and the expected value, it will be 300 times 4 over 35 plus 500 times 12 over 35 plus 600 times 1 over 35 plus 400 times 18 over 35, which is the answer. Part B. In this part, consider an urn U2 contain 3 counters. This is that we solve in a while. U2 contains 3 counters holding each the number 100. So U2, you have 3 counters holding each the number 100. I have 100, how many one? 3. And 2 counters holding the number 200. Calculate the probability of obtaining 2 counters. We draw a counter from U1 and a counter from U2. So let us remember what we had in U1. In U1 we had 100 4 times and 200 3. So we draw a counter from U1 and a counter from U2. You know it's independent, right? Because I want to draw from each urn alone. Calculate the probability of obtaining 2 counter the same number. So I want to have 100 knowing, sorry, for U1 times P of 100 knowing U2, or 200 knowing U1 times P of 200 knowing U2. How many 100 we have here? We have 4, so 1 out of 4. How many 100 in the second? 1 out, independent. 1 out of 4 over 1 out of 7 here, times 1 out of 3 over 1 out of 5. So don't do it together because you cannot independent, two different urn. Plus, I want 200, 1 out of 3 over 1 out of 7 here, 4 plus 3, 7. Here, 1 out of 2 for 200 over 1 out of 5. This is the answer. Can deduce the probability for the sum to be 300. How you can get a 200? Either you pick 100 from the first urn and 200 from the second, or vice versa, 200 from urn 1 and 100 from urn 2. So here, 100 knowing U1 times 200 knowing U2, etc. 100 knowing U1, it's 1 out of 4 over 1 out of 7. 200 from the second one, 1 out of 2 times 1 out of 5, or 1 out of 3 here, you can see it 3 over 1 out of 7, and 1 out of 3 for 100 in the second urn over 1 out of 5. Now, calculate the probability of drawing a counter from U1 holding the number 100, knowing that the sum obtained is 300. So I know that the sum is 200. So that's why I know in U2, what did I draw? I know that I draw from U2 what? A 200, because I know it's a 100. Okay? Calculate the probability of drawing a counter from U1 holding the number 0, knowing that the sum obtained is 300. Okay, so I know that the sum obtained is 300. So to get 100 from the first urn, how many one I have? I have 4, so 1 out of 4 over 1 out of 7. But I know I need to draw 200 from urn 2. How many I have in urn 2? 200. I have 2. So 1 out of 2 over 1 out of 5. The answer will be 8 over 35. So let me take a break so that I can continue. So, number 16, a survey conducted by the medical authorities revealed that 10% of the population are diabetic. So, P of diabetic is 0.1. 70% of these diabetic person have diabetic mothers. So, knowing diabetic, they have diabetic mothers 0.7. While 20% of the non-diabetic person, knowing D bar, they have diabetic mother. As you can see, you have knowing D bar, it means 0.2. We can do a 3 table. If you don't want to do 3 table, you put directly its complement, okay? Here, for example, I'm now going to do a 3 table now because I cannot, it's difficult to type. So if you want, I'm going to do the first step. Here you put P of D, 0.1, okay? P of D bar, 0.9, D bar. Then we put the event diabetic P of mother knowing diabetic, etc. M bar here knowing D. Here M knowing D bar and M bar knowing D bar. Why we have a tree table? Because you have knowing D and knowing D bar. So this will lead us to a tree table. The first question, calculate P of M intersecting D. So it's P of M knowing D times P of D. We have everything. You can get it from tree table. I want then P of D bar intersecting M. So P of M knowing D bar times P of D bar, you have the answer. Deduce P of M, you make the sum of these two, is 0.25. The person interviewed is not diabetic, knowing D bar. What is the probability that his mother is non-diabetic? So when you want to have just the inverse, because I have M bar knowing D bar, I want the opposite. I want M bar knowing, let me see here, in part B, the person interviewed is not diabetic, okay? It's not the inverse, it's the same. P of M bar knowing D bar, I have it already 0.8. You can do it directly, it's not the inverse. In part C, the inverse. The person interviewed has non-diabetic mother. Find the probability that he is diabetic. So, and I have M bar knowing D. I want just the inverse, so I do P of D intersecting M bar over P of M bar. D intersecting M bar, we can find it from the tree table, okay? If you have the tree table, it will be 0.3 times 0.1 over 0.75, which is 0.04. D, the person interviewed has a diabetic mother. Find the probability that this person is diabetic. So come in, I want just the inverse because I have M knowing D. I want D knowing M. So I do P of D intersecting M over P of M. P of D intersecting M, we did it 0.07 over 0.25 is 0.28. What can you conclude? I can conclude that if his mother is not diabetic, the probability of having diabetic will be very low. Okay. Number 17. An urn contains urn A, 1 red, 2 black, and 4 white. Urn, this is the given. Urn B, sorry, contains 1 red and 5 black. So here, how many balls you have? Here in urn 1 is 7, in urn 2 is 6. A player draws randomly 1 ball from A. If it's red, he wins 10,000. If it's black, he loses. So we're going to start. He starts from A. If he get from urn A red, he get 10,000. If it is black, he loses 5,000 minus 5. And if it is white, he draws, he goes to B. He wins 8,000 if it's red. If from B it's red, he will get 8,000. If the drawn board is otherwise, in a red or black, in a black, he loses S. He pay S. Okay, S is a loss, minus. Find the probability of the event the player wins. The player wins if he's going to get a red from A or a white from A followed by a red from B. So we have two choices. Red knowing A. So it's 1 out of 1 over 1 out of 7. Or white from A. We have how many white? 4. So 1 out of 4. As you can see, let me put the laser to see. 1 out of 4 over 1 out of 7. We have A. We have 7 in urn A. Then he go to B. He's going to get a red. How many red in B? We have 1 out of 1 over 1 out of 6. So which is 5 over 21. Okay. Here we did it the first time, the second because independent, because he's going to draw from urn A, then from urn B. Let x be the random variable that designates value of amount upon playing the game. Either he's going to get 10, or he's going to pay 5 or 8, or he's going to lose his S point. Determine the probability distribution of x. First of all, P of 10,000. So to get red, To get red, then it means I have 1 out of 1 over 1 out of 7, 2 over 7. To gain 8,000 is going to get, first of all, white from A, which is white from A. We have 1 out of 4. Sorry, to lose 5 before 8,000. He's going to lose 5,000. He's going to get a black from earn A. So 1 out of 2 over 1 out of 7. 8,000 is going to get a white from A. A white of A is 1 out of 4 over 1 out of 7 times followed a red from B. Red from B, 1 out of 1 over 1 out of 6. And to lose S point is going to get a white from A in 1 out of 4 over 1 out of 7. Then a black from B, 1 out of 5 over 1 out of 6. If you make the sum, it must be these 4, it must be 1. Find the expected value. It will be 10,000 times 1 over 7 minus 5,000 times 2 over 7 times 8,000 times 2 over 21 minus S times 10 over 21. You have this value. Determine S so that expected value is 0. You equate here to 0. So 16,000 minus 10S equal, cross multiply 0 times 21, 0. So it will be 16,000 over 10S is 1,600. This is called a fair game. If S is going to lose 1,600, it will be a fair game for all. Number 18, a cage contains 40 colored birds. So directly put the total. How many male I have? 21. Female, 19. Here I have a 22 blue and I have 18 green, and the total is 40. One bird is randomly caught. Calculate the probability it's a green male bird. Green male. So it's 1 out of 11 over 1 out of 40. A male is caught. What the probability? A male is caught in a knowing male. So the universe now is male here. Only the male. You can see it here. So knowing male. So what's the probability? It's a green. So I have 1 out of 11 over 1 out of 21. Two birds are randomly caught from the given 40. I want to pick 40. Calculate the probability that both birds are green. I want 2 green. So how many green? I have 18. So 2 out of 18 over 2 out of 40. Calculate the probability that both are male. So how many males? I have 21. So it's 2 out of 21 over 2 out of 40 because total. See what the probability that both birds are green males. Green and males I have 11. So 2 out of 11 over 2 out of 40. And the last one, the two code birds are green. Knowing 2 green. So this is the universe. So what the probability they are 2 males? So it's 2 out of 11 over 2 out of 18. This is very simple. Number 19. A class consists of 20 students, 12 boys and 8 girls. We need to pick 5 students. Determine the number of possible outcomes. This is not probability. Possible outcomes, don't forget, it's a combination. So it's 5 out of 20. Calculate the probability of each of the following events. The chosen group is formed of 5 girls, so it's 5 out of 80, 5 out of 8 over 5 out of 20. 2 girls and 3 boys, 2 out of 8 and 3 out of 12 over total. At least one girl. You may have 1 out of 8, 4 out of 12, 2 girls, 3 boys, or 3 girls, 2 boys, or 4 girls, 1 boy, or 5 girls over the total. This is very simple. At most one girl. You may have at most one girl. You may have 0 girl and 5 boys, or 1 girl and 4 boys. Dana is the name of one of the girls in the class, while one of the boys is called Jad. What the probability that they are chosen? So I have one out of 1 and 1 out of 1, which is 2 out of 2, and remains 3 out of 18 I need to pick. If the group has formed of 2 girls and 3 boys, what the probability that Dana and Jad are chosen? Since I have 2 out of 2, remains 1 girl out of 7, and remains 2 boys out of 11, because Jad is one of them, over a total which is 5 out of 20. This is also simple. Number 20, each of the two earns U1 and U2 contains 2 red and 3 white balls. You have the same balls and colors and number. One ball is randomly randomly drawn from U1 and is you're going to draw from U1, and the ball you're going to have, you're going to put it where? In U2. E1, the drawn ball from U1 is red. E2, the drawn ball from U2 is red. E1, knowing E1 and E1 bar, so it's a total probability. If they're going to ask you P of E2, what will be P of E2? P of E2 intersecting E1 plus P of E2 intersecting E1 bar. Calculate P of E2 knowing E1. I know that I have here a red, so this red I want to put it where in earn U2. So U2, instead of having 2 red and 3 white, you're going to get 3 red now and 3 white. So what the probability of getting a red? So it will be 1 out of 3 over, you can see it here, over 1 out of 6. E2 knowing E1 bar. E1 bar not a red, it means I have a white. Instead of having now 2 red and 3 white, I'm going to get 2 red and 4 white. What is the probability of drawing a red? It will be 1 out of 3, you can see it here, 1 out of 2 over 1 out of 6. Deduce P of E2. It will be P of E2 intersecting E1 plus P of E2 intersecting E1 bar. So P of E1, the only thing we didn't do, and P of E1 bar. Probability of getting a red from earn 1, it's a 1 out of 2 over 1 out of 5, which is 2 over 5. You can see it here. Okay. Uh, so 1 out of 2 times, we said 2 over 5. E2 knowing E1 bar is 1 over 3 times not getting a red and getting a white, so 3 over 5, and you get the answer. Now in part B, if instead two balls are randomly drawn from U1 and are placed in U2, after which two balls from U2 are drawn. So I'm going to draw from U1, I'm going to replace the two in urn in the first urn. Let us remember we have 2 red, 3 white. So we have in each urn 2 red, 3 white. Now I want to draw 2 from U1 and I want to replace it. This is U1 or U2, and I want to replace it in U2. R0, the two balls are white. R1, the two balls have different colors. So what is the question? Here. Calculate P of R0. P of R0, what does it mean? The two balls from U1 are white, so 2 out of 3 over 2 out of 5. The two balls have different colors in one red and one white, 1 out of 2, 1 out of 3 over 2 out of 5. R2, the two balls of U2 are red. P, they want to draw P of R2. The two balls drawn from U1, sorry, from U1, not U2. This is U1. U1 are red. So to be red is 2 out of 2 over 2 out of 5. So R0, R1, R2 are all possibilities, so they form total probability. Find now P of A knowing R0. A knowing R0, and I know that the two balls from U1 are white. So these two whites, instead of having 2 white, 2 red, 3 white, so I'm going to get 2 red and 5 white, because two balls white from U1, I want to replace it. What is the probability of having now A, which is different colors? So it will be 1 out of 2, 1 out of 5. Knowing R1, different colors. So here, instead of having 2 red and 3 white, I have 3 red and 4 white, because 1 white and 1 red from U1, I want to replace it here. So to be different color, 1 out of 3 over 1 out of 4 over 2 out of 7, because I have 7 now. And knowing R2 here, R2 are both are red. Instead of having 2 red now in the second one, 4 red and 3 white, I want to draw different colors. So 1 out of 4, 1 out of 3 over 2 out of 7. R0, R1, R2 form total probability because nothing in common. Either 2 red or 2 white or 2 different colors. So deduce P of A, they said. So P of A knowing R0 plus P of A knowing R1 plus P of A knowing R2. So P of A knowing R0 times P of R0 plus P of A intersect knowing R1 times P of R1 plus P of A knowing R2 times P of R2, and you have the answer. Number 21. A factory produces shirt. It was noted that some of the shirt have certain defect. The probability that a shirt has a defect A is 0.1. So P of A is 0.1, and defect B, as you can see here, let me put the laser. P of B is 0.15. The defect A is caused by machine A, while the defect B is caused by machine B. The machines function independent from each other. So A is not affected by B, nor B affected by A. So here, if you want to find P of A intersecting B is 0, nothing in common because they are not, so if you want to find P of A intersecting B, it's P of A times P of B. It's not 0, by mistake I said it. Because A and B are independent, so P of having both defects, suppose you have product, what is the probability that they have both defect A and B? So you P of A intersecting B is PA times PB, since A and B are independent. They said it's independent because independently. Calculate the probability of each of the following events. The chosen shirt has a defect A and B. So P of A intersecting B is PA times PB, so 0.015. Now, F, the chosen shirt has defect A only. To have A only, F, you must, it must have A, and you must, because you have A, B, and the intersection. Some have defect A only, some have defect B, some have both. So to do P of A only, you do P of A minus the intersection. So it will be 0.1 minus 0.015. G, the chosen has defect B only. It will be P of B minus P of their intersection, which is 0.135. K, the chosen shirt has no defect at all. It means, what does it mean, no defect at all? It's 1 minus their union. And we know we can do it in two ways. Either you do P of 1 minus P of A union B, and we know P of union B is PA plus PB minus P of A intersecting B. So it will be 1 minus PA plus PB. We have PA plus PB, we have A and B. Or we do it in another way. If you put the complement of A union B, it will be A bar intersecting B bar. And since they are independent, directly you can do P of A bar times P of B bar. Now it will be 0.9 times P bar is 0.85. If you do 0.9, let me take the calculator, 0.9 times 0.85, you're going to get 0.765 that we have it here. Either you do it 1 minus P of A union B. You know A union B is PA plus PB minus P of A intersecting B. PA here is 0.1, and 1 minus 0.1 minus P of B, which is 0.15, minus and minus plus the intersection. The intersection was E, I think, yes, plus 0.015. If you do it on calculator, it will be the same as 0.765, or you do it as I did here, 1 minus P of E. They have both defect. F, it means A only, G, B only. If you do it, you have three methods. I prefer to do either this one or that one. The factory sells shirt for 20,000, but they offer 20% on any shirt that has defect A only. So if you have A only here, it was, sorry, A only, it was F. Yani if you have A only, F, so what was F? It was 0.085. So you have 20% discount. So you pay 80%, so you pay 16,000. 25% if you have defect B only. P of B, it was G. 0.135. So you pay here 75%, so 15,000, and 40% it has both. It means both. It means E was 0.015. 0.015. 0.015, yes. So here you pay 40%, you have discount 40, so you pay 60, so 12,000. If no defect at all, you pay 20,000. No defect at all, it means 0.765. No defect at all. So let x be the random variable equal to the selling price of the shirt. So you have either 20 or 12 or 15 or 16. Probability of each one. So you know that of 16 is 0.085, that of 15 0.135, that of 12,000 0.015, you have it here, and that of 20,000 is 0.765. Find the expected value. 20,000 times 0.765 plus 16,000 times 0.085 plus 15,000 times 0.35 plus 12,000 times 0.015, and this is estimated amount you're going to get. Suppose you're going to get 2,000 shirts, so what do you expect to get? 2,000 times 18,865, it will be 37,730,000. Number 22. Let me see how many problems remains. We have till number okay, still we have two problems to do. Number 22, a survey conducted on members of sporting club revealed that 35% of the members are football players. So let me draw here a table. So P of football is 0.35. 40% are basketball. P of B 0.4, and the rest, so this is a total probability, are volleyball players. So 70, you have 40, 75 remains 25%. 40% of the football practice tennis also. So P of tennis knowing F is 0.4. So for that reason, P of tennis and football, I need to do all this table because this problem is important, is 0.4 times 0.35. So the answer will be 0.14. Here, the complement, P of T bar knowing F is 0.6. So T bar without writing P, T bar intersecting F is 0.6 times 0.35. The answer will be 0.21. Now, P 50% of basketball, P of tennis knowing basket is 0.5. So tennis and basket is 0.2, and here T bar, knowing basket 0.5. So tennis bar and basket is 0.2 also. And the last one, 60% of the volley practice tennis. Tennis knowing volley 0.6. So tennis and volley will be 0.25 times 0.6, which is 0.15. And the last one, tennis bar knowing V 0.4 and tennis bar and V is 0.4 times 0.25. If you make the sum, all of these, it will be 100% 1. So calculate P of F intersecting T, you have it. P of B intersecting T, you have it. P of T intersecting V. If deduce P of T, it will be this sum plus this sum plus this sum. Okay, you have it here, is 0.49. Now the chosen member practice tennis. What the probability he's a football player? We want P of tennis, football knowing tennis. Since I have another just opposite, I have T knowing F, I want F knowing T, so I put the property. So P of F intersecting T over P of T, it's 2 over 7. The member in this club pays a monthly subscription of 15,000 for foot, 20,000 for basket, 18,000 for volley, and if he practice more tennis is 25,000. So how many possibilities I have? We can have football only, F only. This is for F only. Without tennis, yani I mean F and T bar. The first one, F and T bar. We have everything in the table up is del F and T bar. F without tennis 0.21. So he's going to pay what? 15,000. Now, if I want F with tennis, F with tennis 0.14, they must pay the 15,000 and the 25, so he must pay 40,000. If he's going to do basket only, it means basket and tennis bar. Without tennis, it means. So basket and tennis bar 0.2. He's going to pay only the basket 20,000. And if he's going to play tennis with it, come in 0.2, you can see it here. So he's going to pay the 20 and the 25, 45. He's going to do volley without the tennis. Volley without the tennis is 0.1%, 10% of the student. He's going to pay 18,000, and volley plus the tennis, volley plus the tennis is 0.15. He's going to pay 18 plus 20,000, so it's 43,000. So these are the four possibilities. So P of 15,000 is 0.21. You can see it here. P of 40,000 is 0.14. P of 20,000 0, etc. In this kind of problems, when you have random variable, you need to notice, please bear in mind, each outcome will be the outcome of one of the random variable, okay, because the sum must be one. This is the outcome of all. Okay, that's why I did all parts of this problem. I have drawn the tree table in front of you to tell you that each one of these, when you have a tree table and they're going to ask about random variable, each one will be one of the values of the random variable. Then what is the expected value? 15,000 times 0.21 plus 20,000 times 0.2, etc. So you are expected to get from each player 30,000. And if you have the last one 200 players, so what do you expect to get as revenue? It will be 200 times 30,000. You're going to get 6 million Lebanese lira. Okay, so